Hello and welcome to the YouTube channel of AI with Vic. We are getting started on the basics side of ML, and the first and most important library in this series will be NumPy. We will explore other libraries as well, but let's start with NumPy. So what we will try and do today is like we will try create arrays with the help of NumPy, explore array attributes, try out different data types and memory on arrays, reshape it, and probably try and explain with a small practical example, right? So the first question is that why NumPy? Why do we actually use NumPy? So NumPy provides like the fast vectorized operations. It also has less memory compared to the Python lists, and it forms the very foundation of machine learning, AI, and other scientific computing. Wherever you go, whether you are trying to research higher in computer science or in mathematics area, NumPy will form a basic kind of a library for you to understand and use it in or throughout your research or in your job also if you are trying to get into one of the data science job or machine learning jobs. It the most important point of understanding NumPy is that NumPy is the basis for image processing, like different kinds of image transformation or image augmentations that you might learn in future or apply in computer vision are being held with the power of NumPy, right? And the other most important part about NumPy is that it integrates seamlessly, like it's applied across all the libraries that you might come across in data science, whether it's scikit-learn, whether it's pandas, whether it's torch, or there's another library called QPy. QPy is built on NumPy, but it runs on CUDA, like on the GPU platforms. Okay, so that is why NumPy is very necessary. Now, after this introduction, let's start by understanding how we can create arrays in NumPy. Like, so I have declared an array called A and B, right? But let's declare an array using arrange function, right, in NumPy. An arrange function in NumPy acts in a similar way, like the range function in Python lists, right? So let's just see how does it act. 0, 10, 2. So the output of this particular function will be like 0, 2, 4, 6, 8. It will not touch 10, obviously, like it does not does in range. Like let's print this out. Print C. You can see 0, 2, 4, 6, 8. Similarly, there is another function called linspace, right? And linspace can be declared as np dot linspace, right? And we can take 0, 1, 5. This basically gives you an equidistant interval. So let's see how does it do. Print it. Yeah, equidistant intervals of 5, 0, 0 0.25, 0 0.5, 0 0.75, 1. If you could have done it 2, it could have resulted in 0, 0 0.5, 1, 1.5, and 2, like 5 equidistant intervals, right? Okay. The other type of arrays that I would like to show is the zeros, ones, and an identity matrix also. Let's try and understand the zero. Np dot, you can just declare it by np dot zeros. Let's say I say 2, 3. What does it mean? That we will have a zero of a 2D array, right? A 2D array of 2 rows and 3 columns, right? You can see here 2 rows and 3 columns, zeros. Similarly, we can declare ones also in the similar manner. Np dot ones, let's say we declare it 2 comma 4. So it should have 2 rows and 4 columns, like a 2D array. You can say 2 rows and 4 columns, and the last is the identity one. So g is equal to np dot I, let's say for example 4, right? Print g. Let's see, you can see the identity array or the identity, you can say matrix also, right? uh, if you have a very little idea about the matrices, types, and operations, I will attach a link in the description. You can basically go through that link and understand matrices types and the different types of operations we can perform on top of matrices. Okay. Moving on. Now let's discuss about the attributes. Like let's say for example, what are the attributes that an array carries? Let's see. Let's say that we declare a array B which has got like 2 rows and 3 columns. So let's understand print B dot shape. It basically shows what is the shape of the array, like 2 rows and 3 columns. You can see here. Yeah, 2 rows and 3 columns. The other attribute that we can understand is dimension. What do you mean by dimension? So dimension basically shows that whether the array is 2D or 3D. Let's say for example this is 2D here, right? And again we can declare, can get the data type also, d type, which is int 64, int 64 or int 32 depending upon your system that you are using, right? Okay, uh, let's now discuss the other part, which is data types and memory. So if every element in the array has got some data type, right? And it has got the same data type also. Like let's say for example, if I declare this particular array to have a data type of int 16, so it will have a data type of int 16, right? So also, like let's say for example, if I say this is 32, what will it show? Print array dot d type, and then if I print array dot item size, you can see 4. Why 4? Let's change this to 16. Why 2? Right? So this basically the declaring the data type changes the bytes per element, right? Let's say for example, if this is 16, then what would be the total memory here? Can you guess? It's 6 bytes, right? Let's see here. Print array dot n bytes, 6 bytes. If I change this to, let's say for example 32, it becomes obviously 4 4 4 12. What if I change it to 64? 24, right? Okay. The other important aspect of array, let's discuss that, is reshaping. So what does reshaping allows you? Reshaping allows you to organize the data right in the correct format or whichever you want. It doesn't change the nature of the data, it changes the view of the data. What do I mean by that? Let's say that I want the data to be viewed as x2 is equal to np dot reshape x2, oh sorry, this should be x dot reshape, and this should be 3 comma 4. So this will actually give me a 2D array, right? This whole thing will be converted into the 2D array, and this is what, let's say this is index. This is a one-dimensional vector, you can say, which is converted into a 2D array having 3 rows and 4 columns. 3 rows and 4 columns, but the nature of the data is not changed, right? The view is changed, right? So this is how I want to view it. Let's say for example, now I say x3 is equal to x dot reshape into 2 comma 2 comma 3, and let's see print x3. What do I get? Again a 3D array here, right? So basically you can by the way, we can get this back also, right? So basically what you are trying to do is you are changing the view of the data or reshaping it, but you are not altering the very nature of the data here. Okay, so okay, so now we will try and understand using a practical example, right? Let's see this first. Like we have this image here. Okay, and yeah, this is the image, this is the original image that we have here. Let me just show you. Okay, let's just first load this, and then this you can see here, it's an array, right? It's an array. Let's see the array shape. 225 rows, 300 columns, and having 3 channels. What does this mean? This is basically a representation of an image here. An image is represented like this, and it has got 3 channels. The 3 channels are basically red, green, and blue color, right? And what you see here are the pixel intensities, right? 45, 50, 72, and those are the pixel intensities. We will try and show a small example of how we load the image, how we normalize the image, have the brightness increased, and then again show the brightened image in the normalized form. So let's start understanding the code. So we load the image here, right? And we convert, like, basically if any element in the image is less than equal to 1, we just try and multiply by 255, and then we normalize it like between 0 to 1. Then we increase the bright factor, like basically we increase the brightness of the image by 40%, and then we try and clip it. So what does clipping does? Is basically, you have seen here that we are normalizing it, right? We are saying that, okay, this is the image norm that you have got, and multiply it by 40%, but keep the pixel values only between 0 and 1. That's what np.clip does here. And at the ultimate end, we then convert it into the original form, like into the 255 form that we originally is represented in the images, right? Like image bright cross 255 here, right? Now what is the sequence that we will show? Like, let's say for example, this is the first image that you see here is the original image. After that, what you have done is basically you have brightened it. How? We have first normalized it and then brightened it. Normalization, again I will repeat, it's a process to present your data between 0 to 1, right? All the values that are there will be represented in 0 to 1 in an array, right? So when you brighten it, you can observe that the small grills here, you can see the black color grills have been brightened here, right? And you cannot observe them here, right? So it has been brightened. And then again, this brightened image is again converted into the 0 to 255 form, like basically into the uint8 form here, you can see here, and then shown again, right? So they are basically the same. So it's just that we are converting it back and reconstructing it again in the 0 to 255 form and showing it. Okay. So yeah, this is a small operation that I tried to show with the help of NumPy on an image. Remember, there will be a lot more operations as we go forward. NumPy is one of the basics library that you should master if you are trying to go into the AI data science, right? And it will help you a lot in image processing, a lot, right? Okay, with this we come to the end of episode 1. I will attach the code links in the description also. If you like this video, please like and subscribe. Thank you.